In Lesson 1-9, you will learn how to solve addition and subtraction equations. Our first vocab word is inverse operations. Addition and subtraction are called inverse operations because they undo each other. You will use this idea to help you solve one-step addition and subtraction equations in this lesson. Subtraction property of equality is the idea that if you subtract the same thing from each side of an equation, the two sides will remain equal. For example, if you want to solve x plus 5 equals 3, the first thing you're going to do is you're going to draw what I call train tracks around the equal sign. This is nothing more than a visual to show you the two sides of the equation. And whatever you do to one side, you must do the exact same thing to the other side to keep the two sides of the equation equal. Basically, your goal in equation solving is to isolate the variable or to get it by itself. If I want to get this x by itself, I'm going to ignore it for now and get rid of this extra stuff with it. In order to get rid of this plus 5, or to get it so it's 0, I want to use the inverse operation, or subtract 5. But if I subtract 5 from the left side, I have to also subtract 5 from the right side. When you're showing your work on your homework assignment tomorrow in class, you're going to need to show these steps. Now on the left side, this positive 5 plus the negative 5, or the plus 5 minus 5, that's 0. So some people will just cross it out. I like to put a big 0 on it because that's what it is. And x plus 0 is just x. And on the other side, I have 3 minus 5. 3 minus 5 is going to be a negative 2. If you don't recognize that, you might need to change it to adding the opposite. 3 plus a negative 5, they're different, so you would subtract and keep the sign of the number with the greatest absolute value. So I have my answer as x equals negative 2. Now the next step is to check your solution. The nice thing about equation solving is you can always go back to your original problem, plug this in place of the variable, and see if it works. So I'm going to plug in negative 2 for x. Negative 2 plus 5 should equal 3. Negative 2 plus 5 is 3. Since 3 equals 3, we know we've got the correct answer. Now might be a good time to pause the video and try the next 3 on your own. In order to get a by itself, we're going to get rid of this plus 6 by subtracting 6. We're using the inverse operation. When I take away 6 from 6, I get 0, and a plus 0 is just a. And on the other side, 2 minus 6, that's going to be a negative 4. If I wanted to check my work, I would take my answer of negative 4 and plug it back into the problem. Negative 4 plus 6 needs to equal 2. Negative 4 plus 6 is 2, and 2 equals 2, so we know we have the correct answer. There should be absolutely no reason for getting these wrong on your next quiz or test because you can check them all before you turn them in. Next example, draw your train tracks, and to get rid of the plus 3, you're going to subtract 3 from both sides. This positive 3 take away 3 is 0, so you have y equals, now negative 8 minus 3, you might want to change that to adding the opposite. Negative 8 plus a negative 3, that is negative 11. So I'm pretty sure my answer is y equals negative 11, but I'm going to check it just to make sure. In place of y, I'm going to put negative 11. Negative 11 plus 3 should equal negative 8. Well, negative 11 plus 3 is negative 8 because they're different signs. You subtract the 2, you get negative 8 equaling negative 8. In our last example, draw the train tracks. This time the variable is on the right side instead of the left. It doesn't matter. If you'd prefer, you could rewrite it by switching these two sides. You could do n plus 4 equals 5 if you're one of those people that always like the variable on the left side. I'm just going to go ahead and do it the way it's written. To get n by itself, I'm going to get rid of the plus 4 by subtracting 4, because a positive 4 minus 4 is 0. If I subtract 4 from the right side, I need to subtract 4 from the left side. 5 take away 4 is 1. I'm pretty sure the answer is n equals 1. Let's double check it by plugging it back in. 5 should equal 1 plus 4. 1 plus 4 is 5. Since 5 equals 5, I know we have the correct answer. We have one more example of an addition equation. Two angles are supplementary if the sum of their measures is 180 degrees. The two angles shown are supplementary. Write and solve an equation to find the measure of angle x. So we're trying to find this measurement right here if we know these two angles are supplementary. Since they're supplementary, I know that this one, or x, plus the other one, which is 94, has to total 180 degrees to be supplementary. Now if I want to solve this equation, I'm going to draw my train tracks. To get x by itself, I will need to get rid of the plus 94 by subtracting 94 from both sides. On the left side, positive 94 take away 94 is 0. So we have x on the left. And now 180 take away 94. I can't take 4 from 0, so I'm going to make this 8 a 7 and the 0 a 10. 10 take away 4 is 6. Now I can't do 7 take away 9, so I'm going to go over to the 1 and make it a 0 and make the 7 a 17. 17 take away 9 is 8. That means the measure of angle x is 86 degrees. The addition property of equality says if you add the same thing to each side of an equation, the two sides remain equal. So in the first example, I'm going to draw the train tracks. This time if I want to get y by itself, I need to get rid of this minus 7. To get rid of minus 7, I'm going to add 7. This minus 7 is really like a negative 7. And a negative 7 plus 7 is 0. If I add 7 to the right, I have to add 7 to the left as well to keep it equal. Negative 6 plus 7, they're different signs, so I'm going to subtract the two numbers and keep the sign of the one with the greatest absolute value. So I get 1, and on the other side I have y. Therefore, y is going to equal 1. Now, if you wanted to check this, you would plug it back in. 1 minus 7 equals negative 6, so we've got that answer correct. Now would be another good time to pause the video and try a couple of these on your own. In the equation x minus 8 equals negative 3, we want to get x by itself, so we're going to get rid of the minus 8 by adding 8. If I add 8 on the left, I have to add 8 on the right to keep it equal. This minus 8 and plus 8, or negative 8 plus 8, is 0. So I'm left with x on the left. And on the right, negative 3 plus 8, they're different signs, so I'm going to subtract the two numbers and keep the sign of the one with the greatest absolute value. So I'm pretty sure my answer is x equals 5. You can check it by plugging it back in. 5 minus 8 equals negative 3, and that is correct. Draw your train tracks. In the equation b minus 4 equals negative 10, we're going to start off by adding 4 to each side to get rid of this minus 4. b minus 4 plus 4, or a negative 4 plus 4, ends up being 0, so we have just b on the left. And on the right side, negative 10 plus 4, they're different signs, so you're going to subtract the two numbers and keep the sign of the one with the greatest absolute value. Now to check your work, you're going to plug that back in. Negative 6, take away 4 more, is negative 10. Now our last example, to get the p by itself, we're going to get rid of the minus 12 by adding 12. Seven plus 12 is 19. And on the other side, this minus 12 plus 12, or negative 12 plus 12, is 0. So we end up with just p on the right. So our answer is p equals 19. Now to check it, you plug that back in. 19 take away 12 is 7. So that one is correct as well.